question 6 from Module 2, and it's an interesting question. So you can get a policy where the grandparents, you have a child, the grandparents or parents want to make the following 6 payments to some insurance company. So on each birthday, they deposit a different amount of money until the kid turns 6, and then at the age of 65, the child receives $300,000. The big question on this is what happens if the discount rate changes. So it's 11% for the first 6 years and 7% for all subsequent years. Is the policy worth buying? There's a lot of different ways to do this problem, and I'm going to show you one of them. So first, let's set up the payments. So year 0, 1, 2, 3, 4, 5, 6. The 500, 600, 700, 800, 900, and 1,000. Okay, so the first step is to figure out the present value of these payments. So these are the payments. This is the present value. And then we'll sum it and do the net present value. We add a line so we can do our interest rate. The interest rate for the first 6 years is going to be 11%. Alright, and the payment here is 0, so this is going to equal that divided by 1 plus our interest rate, which we're going to lock, to the power of time. Payment divided by 1 plus the interest rate to the power of time. Those are all of those. Let's hit escape. Sum. Alright, so let me put this in a fancy format so it's easier to see. So the net present value of these payments is about $3,000. Now, the question is, when the kid is 65, if you get $300,000, so he gets $300,000, is it worth it? It's 7% discount rate for all subsequent years. There's a couple different ways to get the present value of this cash flow, but an easy one would be so we know that for the first 6 years we have a discount rate of 11%. But we know that we can just multiply, or when we're dividing by interest rates to the different powers, we can sort of chain them together in order to make one long interest rate. So we can do 1.07 to the power of 65 minus 6 would be 59. And let's close the parentheses. So I have a bunch of parentheses here just to make sure that Excel doesn't do anything weird with the formatting. Oh, they found a typo. Let's see if it works out. Did we divide everything correctly? There we go. So the present value of this cash flow, and let's subtract these. Okay, so notice that these are payments. I'm going to give this a negative. Actually, let's do it this way. So these are all negatives. This is outflows. This 300 is a positive because it's an inflow. They paid us that money. So the sum for these two projects is going to be minus $83. So it's not worth our while to invest in this, I don't know, annuity or whatever it is for our child, because the net present value is minus $83. So even though $300,000 at 65 years old sounds like a lot, we actually lost money on this transaction. And if you were to scroll down, you would see that we lost $83 on this, and we should reject the policy.